Okay, finding a point with a given gradient. If you're asked for the point on a curve with a given gradient, follow these steps. So here's our example. Find the point on the curve where the tangent line has the given gradient. So here's our function, our curve equation, and we're given this slope for that tangent line. Step one, we're going to go ahead and differentiate the function. So we're going to use our power rule and differentiate it. All right. So here's our function, f dash x equals, bring down the 3x, subtract the exponent, minus 9, bring down the 2x, subtract the exponent, plus 13, bring down the 1x, subtract the exponent. The last term, negative 2, is a constant, so that just becomes 0. Continue. 3x squared minus 9 times 2 with a negative is negative 18x plus 13 times 1 is 13, and then x to the 0 power is 1. So here is your derivative function. Step 2. After you found that derivative function, you're going to substitute the slope or gradient into the derivative function that you found up here to find the x value. In this problem, you'll get 2x values. So here we go. So we have that slope, which was negative 2. And we're going to substitute it in for the f dash x. So I'm just going to write that derivative function again. And we're going to substitute the slope into the f dash x. So negative 2 equals, and then 3x squared minus 18x plus 13. What we have is a quadratic equation, and we want to find out what x is. So in order for us to do that, we need to get it into standard form. So I'm going to add 2 to both sides to move that negative 2 to the right side. So 3x squared minus 18x plus 13 plus 2. And I'm going to simplify it. 3x squared minus 18x plus 15. So what we have is a quadratic equation. We want to find out what x is. So thinking back to our quadratics topics in Algebra 2, how we solve quadratic equations is factoring or quadratic formula. So this equation can be factored, so we're going to take out the GCF first, the greatest common factor. So the greatest common factor of all three of those terms is 3. So we're left with x squared minus 6x plus 5. Now we have to factor this quadratic piece. So think about, what are the factors of 5 that add to negative 6? So factors of 5 that add to negative 6, they are negative 5 and negative 1. So continue. 3x minus 5, x minus 1. Now we have it factored. Now we use our zero product property. And we set those factors equal to 0. Here's our first factor, and there's our second. We set them both equal to 0. So x minus 5 equals 0, and x minus 1 equals 0. And we solve them for x. So we're going to add 5 to both sides. We're going to add 1 to both sides. So what we have are two answers. two x values. All right, continuing on. Step 3 is we need to find the y values. So to find the y values, you substitute the x values in the previous step into the original function, the original equation. So here is the original function, f of x equals x cubed minus 9x squared plus an extra parentheses here, 9x squared plus 13x minus 2. And those x values on the previous slide is what we're substituting in. So let's start with x equaling 1. So you say f of 1 cubed minus 9 times 1 squared plus 13 times 1 minus 2. All right, to quicken this up, you all know how to do orders of operations at this point. So when we're done simplifying it, f of 1 equals 3. So what did we get? This is the point at which the curve touches the tangent line and your original function. So here's step 4. Now you one more time. Let x equal 5. Substitute it into the original function, f of 5. So 5 cubed minus 9 times 5 squared plus 13 times 5 minus 2. Simplify all the way down using your order of operation and PEMDAS. F of 5, you'll produce negative 37. So here's the second point at which the tangent line and the curve will touch. So you write them as ordered pairs. All right. Then what you can do is you can go ahead and graph these two functions with your graphing calculator. So you have your original function y equals x cubed minus 9x squared plus 13x. And what will happen is you'll get a snake, something like this. And you're going to get tangent lines with slope of negative 2, and they're going to touch at 5, negative 37, and over 1, up 3. So let's say this is 1, 3. You'll have a tangent line, a negative tangent line, with a slope of negative 2. Then you'll have another ordered pair over 5 down 37 and have another tangent line of negative 2.